This is a brief introduction to NoSQL. Keep in mind, NoSQL is a category of relatively new technologies and products, and NoSQL is still evolving. Here are some characteristics about NoSQL. NoSQL is not relational. We use NoSQL for storing big data and processing big data in a distributed environment. NoSQL is open source, but keep in mind, if we want to use NoSQL for mission-critical applications, we may still need to pay a licensing fee to get some advanced features which are required by the mission-critical application. We tend to use less expensive hardware with NoSQL. NoSQL processes data in a batch mode. The Google MapReduce is commonly used, but NoSQL can also provide interactive and streaming processing. In those scenarios, the Apache Spark and Facebook Presto are commonly used. NoSQL tends to have redundant data for improving the read operations. The redundant data will speed up the query performance. Generally speaking, NoSQL databases are schema agnostic. The Facebook Presto was built from ground up as an interactive SQL processing engine. Presto can work with all types of data sources, including NoSQL and relational databases. Here are some characteristics about big data. Big data has large volumes of data. Big data is both structured and non-structured. Generally speaking, big data is generated very fast. Big data needs to be captured, stored, and analyzed very promptly. This is the so-called 3 V's of big data. There are 4 types of NoSQL databases. We use key value and columnar for storing simple data. We use document, graph, and triple store for storing more complex data. We also have NoSQL technologies and products for analytics and data warehousing. In those scenarios and use cases, Hive, Redshift, Presto, and Airport are commonly used. Here is a quick look at NoSQL database use cases. In summary, we use key value columnar for storing relatively simple data, and for more complex data or data with complicated relationships in it, we would use document, triple, and graph. This is another perspective about NoSQL database use cases. We tend to use JSON and XML to help structure the content of the document database. Here are some data formats of NoSQL databases. Pay attention to the timestamp. Remember, NoSQL tends to duplicate data, or NoSQL tends to have redundant data for improving query performance. We need to use the timestamp to determine the current version of the data. Some characteristics about NoSQL operations. NoSQL operations use a lot of memory. NoSQL tends to store and process data in a distributed environment. NoSQL tends to have a proprietary interface, but we could probably find a SQL-like interface for any NoSQL database. Here are some common examples of SQL-like interfaces for NoSQL. HiveQL and Pig are part of Hadoop. Cosmos is Microsoft's enterprise data warehouse. We use Scope to query Cosmos. Scope is the SQL-like interface for Cosmos. We can use this comparison chart for comparing NoSQL to DBMS. Generally speaking, NoSQL stores unstructured data. DBMS stores structured data. NoSQL tends to process data in a distributed environment. DBMS can also do that, but it's less common. If we care a lot about data integrity and we want to process transactions, then we will want to use DBMS. If we just have a lot structured and unstructured data, we need to quickly capture, store, and process, then most likely we will use NoSQL. Here are some SQL-like commands for NoSQL. This HiveQL example creates a database. This HiveQL example creates a view. This scope example does an inner join. This scope example does a left outer join. We can see the SQL commands for NoSQL are just like the standard SQL with some very minor variations. This concludes our brief introduction to NoSQL.